right. So just a quick check, right? How many of you have actually worked in AR or done any AR development? Okay. All right. You're in for a big disappointment because I'm not going to teach you anything new. No. All right. So just a little background here. Okay. I work for a company called Zebra Technologies, and we make Android devices. We basically make special purpose Android devices that are ruggedized, uh, basically have a 4-foot or a 6-foot drop resistance. You can, and if you go to a Home Depot or a Walmart or Target, you'll see associates carrying these basically Android devices with scanners on them. They scan. So they have integrated barcode scanners, right? And they're basically, I would say, high to mid-range, mid to high range Android platforms. Like in our case, the chip platform is an SD660, which is the high end. Okay, so it's the same, almost the same chipset that's in the Google 3A, Pixel 3A. Okay, but the thing is, we make these devices in multiple formats, like some that look like hardened cell phones, but others that are basically have triggers and handles and so forth for more customized warehouse kinds of applications. We also have a variety of these kind of devices that are carried by healthcare, by nurses and others like that. So there's a lot of industry verticals that we play in. It's not a very high volume, but the interesting thing about our products is that they're used by associates 24/7. Okay, so among those that have actually worked or been exposed to AR Core or AR Kit, how often do you actually use as a user? How often do you actually use the apps on your device, in the AR apps in the device? Can you say once a day? Anyone? Okay. Typically, what happens is that once you buy your device, once you start playing with it, you usually start working with these kinds of apps, that are there. The current app focus is like beer pong, right? Why? By the way, do you know why beer pong was such a big showcase for augmented reality? It's because beer pong is really a multiplayer game or two-player game, anyway, right? So you have to have a device in my hand looking at a scene, and then another person who's playing with me also has to have an Android device looking at the scene. And the two scenes must be somehow geo-registered, right? And that's why it became a very interesting, popular exercise for multiplayer AR experiences. And of course, you've seen these, right? You see on your viewfinder, you can put in a whole bunch of icons that move around, and this is again something that you do once, video it and show your kid or whatever, and that's the end of it, right? Then you have about 1 million of these measure apps. By the way, that's kind of interesting. Why all those measure apps, right? And it turns out that the inherent capability that AR, augmented reality frameworks now offer is the easy reflection of that is the measure apps. But you can use that, the fundamentals behind that measure app in a lot of enterprise applications, which is what my talk is going to be about. And of course, you have all these furniture placement things, right? Try out IKEA furniture in your living room and that sort of thing. But beyond these four categories of apps, if you as a developer, by the way, if you want to make any money on it or get some revenue out of this, good luck, because it's saturated. This market is saturated, way saturated. So I'm here to tell you that there is another market. There's a whole bunch of other markets that you can look into, right? That you can actually make money on, and that's going to be the vertical enterprise space, right? So basically, there's a whole bunch of ROI, return on investment kind of things. The interesting thing about many of them is that augmented reality can be brought into play in these verticals. without actually investing in a lot of infrastructure, additional infrastructure on the part of your customer. And here's a few examples that I'm going to be showing you here in all of these kind of vertical use cases where augmented reality as a framework can yield a whole bunch of very interesting use cases and applications. So good so far? All right. Let's go try to find out how. By the way, confessions here. I'm not really a developer. Wasn't anyway a year ago. I was a product manager. I attended the Google I/O 2018, right, where they talked about AR core, and I went back and said, hey, you know what? We gotta get. I see a lot of interesting enterprise applications here, and see if we can make that work. I couldn't really get any energy, in our own company, to work on this. Okay, so I said, you know what? I'm gonna start learning to do both Android development and AR core development on top of Android in my spare time. And that's essentially what I did over the last year. And what you're going to see basically is the result of that. So, bottom line is that we were lucky to get our devices certified by Google as AR core certified. By the way, unlike a whole bunch of other certifications like Android certified or Google Play services certified and so on, which are all basically rubber stamps, right? AR core certification is a lot more complex than that. You'll see in a minute why that is. Because going back here, see that the AR framework over there? This thing is, the AR framework over here. And that is working on the camera and the IMU within the Android framework, and he's doing all the heavy lifting. Now, you will find out in a minute that the IMU and relative placement, physical placement of the inertial measurement unit, which is the accelerometer and the gyro on the device, and the camera, they're all precisely have to be aligned, and it is different for every device, right? Every model, every cell phone that you have, it has got a different configuration. Each one of those configurations has to be calibrated for by Google themselves. So if your device is AR core certified, qualified, that device has gone through the 6-week process of certification by Google, which is why, and because it takes a lot of engineering resources to do that, right? And so they are very restrictive on which devices actually get qualified. So you cannot just take any Android device and make AR core work. Now, Apple has an easier job of it, obviously, because they control all the hardware, right? So almost every Apple device out there is ARKit certified, but in the case of Android, only a few of them are. But anyway, 4 of our Zebra devices are qualified, and therefore they can start hosting applications. So, by the way, how many of you are familiar with a predecessor to AR core called Project Tango? Anyone? Okay, yeah. So Project Tango had was only supported on a couple of devices, like the Asus Zen something device. That basically they had special purpose hardware. They had a stereoscopic camera in the back, and basically when you have that, you basically can infer depth sensing, and you can start developing point clouds, right? So okay, now we can all get our arms around how that can work with augmented reality. Because you're developing a point cloud as you're walking around. Now, but how can you do that, right? I think the real breakthrough with both ARKit and AR core is the way that this is done with just one camera, a single camera. How can you do point cloud development with a single camera, right? Have you ever wondered that? Okay, well, the interesting thing about that is that's where the accelerometer and the gyro that are on the device come into play. I'll give you an intuitive explanation here, okay? Supposing I have my device, half a pixel in this case. I take a picture here, and then I move this device over here, take another picture, right? And the accelerometer and the gyro on the device, right? What is the accelerometer? It measures acceleration, right, in 3 dimensions. And if I double integrate the acceleration, I get the displacement, correct? And I single integrate the rotation rate, I get rotation. So if I single integrate the inertial sensor gyro and double integrate the accelerometer somehow, right, I can actually get the relative displacement, right, of the device from the time I took this picture and the time I took that picture. What is the same as? Taking a stereoscopic thing with a known baseline, right? So now we are back into the tango territory. So that is the basis for which, on which these both AR kit and AR core work. And it's a lot of heavy lifting. There's a massive Kelvin filter that is running around inside of this and on every frame. So every frame of data, you're tracking points, right, in the space. At the same time, you're integrating the accelerometer and the gyro data. All of that is happening. By the way, all of that is happening. You don't have to worry about that yourself, because all of that is being given to you over here in that AR framework, right? So all you have to do is use that in your application. Okay, moving on. Here's kind of a pitch pictorial of what happens when you know that most of these AR applications, you're moving your device around until a moving hand stops or something. And basically what you're doing is searching for surfaces, searching for points on the surface. You're mapping out the surface that you have detected. You can detect multiple surfaces. And then you start developing your own position. So bottom line is, once you start detecting a sparse point cloud, then you can start mapping the position of this device relative to the point sparse cloud, assuming that the point cloud is stationary. You see what I'm saying? So now you're locally tracking your device. Okay, precisely, very precisely, down to, when I say locally tracking a device, I'm talking about finding the XYZ position, the 3 axes, and also the pose of the device, the actual orientation of the device, also in 3 dimensions. So you basically have these 6 numbers, right, that completely define the pose of the actually it happens, it turns out it's 7 numbers, because the rotation is a quaternion. So these 7 numbers actually define your total your position of your device, but it is only relative. This is the most important thing that you should know, is that when I'm tracking, in AR world, the relative the sparse point cloud, that tracking is accurate, but it is relative to some unknown origin. Some unknown, you have no idea what that origin is, okay? And it's only relative to that origin until you lose track. When you lose track and you reacquire the scene, you may or may not have the same origin. And that is the biggest boogaboo of augmented reality in these smartphone frameworks. And now, go back to those consumer applications we saw, right? Measure app, put your sofa in your living room app, and all those. All those are basically what I would call very temporary, applications where in the current scene, you place an object and you admire it, right? But if you want to reproduce that object in that same location, but from another person, another device, another session, right, later, tough luck. You cannot do that. And that's why you need this additional concept of persistent anchors, which I'll be talking about. So working with frameworks, as I told you before in my confessional, that I'm not a developer. So I struggled with Unity. I couldn't make it to work. In the Android world, in the native Android world, you have 2 versions, 2 options. You can work in AR Core, which gives you a pretty low-level control, but that is OpenGL ES. Again, that proved to be beyond my capability. So I basically went after scene form, which is much higher level. And basically, you think of the whole world in the form of a tree of nodes, and you can manipulate those nodes. And it was just at the right level of sophistication for my growing capabilities at that time. Okay, so basically, I went ahead and built. By the way, most of you, this is how you learn, right? Whether you're an autodidact or not, you learn by looking at code. And so I looked at the code on the samples, and I built this solar system app from the samples folder. And this was my first foray. At this point, I had maybe Android Studio open for maybe a few days for the first time in my life, right? But that actually, obviously triggered the excitement, right? So I took this app and also the original scene form app and started walking around my neighborhood Walmart and to see, okay, what can I actually do with this, right? And the answer we'll talk about in a few minutes here. So one of the, as I mentioned before, persistence, or to be able to find created a augmented reality session from one device to another, one time to another, one person to another, or imposing a predetermined 3D world onto a scene that you're seeing. All of that requires persistence or georegistration. But the first part of persistence is pretty straightforward, which is basically how do you persist all these augmented object classes, node classes, and so on from put it away in a shared preference or a Firebase or whatever, right? So you got to figure out. I mean, all of you are seasoned Android developers, so you know what I'm talking about here. Basically, to be able to serialize it, and I basically created some Kotlin classes. By the way, most of the samples are in Java, of course. But Kotlin actually works really well, for this, because you can build a whole library of extension functions because you need them. You need, in order to make this thing work, so that you don't read, go back to fundamentals for every little thing that you want to do. Anyway, but the bigger problem is the second bullet over here: the persistence to restore the device pose from one session to another session. Like I said before, so there is different ways of doing it. One is obviously cloud anchors. So now cloud anchors, the idea there. Remember the idea that I shared earlier. I said that the beer pong. We're both playing beer pong, and I'm looking at the scene, and you're looking at the scene, and how do I correlate the two scenes together? And obviously, cloud anchors is one place what Google suggested. They said, okay, you go create a cloud anchor with one user. The second user pulls it down from the cloud and then reconstitutes the anchor points so that your anchor and my anchor are now co-registered so that we can both look at the same scene in the same coordinate system. So that, by the way, requires the cloud anchor development depends on the use case, but some use cases it may be okay. But what if your use case has to have you register yourself, say, on every 3 or 4 foot shelf in a Walmart that's got 2,500 4-foot shelves? So you have to create 500 cloud anchors, and each cloud anchor basically requires you to walk around the area for about 10 seconds and create that, and then you send it up. So, but there are use cases where cloud anchors will work pretty well, because if you're picking in a small area and you want to anchor it. But also cloud anchors, something else to remember is that you need to separate objects that are transient from the objects that are permanent. Right? I mean, if this guy with a red shirt is standing here, sitting in the room, he is going to be part of my cloud anchor. He walks away, right? So how do I, and I may or may not be affected by by that part of the cloud anchor walking away, right? So the other one is much more common is image anchors, right? Basically, remember that all the augmented reality applications before AR Core, like Euphoria and all, they all had markers, right? Image markers. So that's basically an extension of the same thing. That works very well, but it depends on your scene. It depends on your customer, your application, end user application. Like if you're in a retail environment like Walmart or Target or whatever, where the marketing determines exactly what kind of things you can have in the store, not the IT department, not the developers. If they and they will not let you put big pictures, arbitrary pictures or QR codes in all the aisles. You have to live with whatever system they have, right? So images are good for some things, but not for others. In fact, one concept that we have in a big warehouse kind of environment to actually have a big, massive cube on the roof, 30-foot high, with multiple pictures on each one of them. So you can just look at it and register yourself. So that works for that. Okay, but you cannot do that in Home Depot or Walmart, right? But anyway, and then we also have barcode scanners, right? The interesting thing about barcode scanners is that all these stores and other places have lots and lots of barcodes. So if I can capture the position of my device and my pose of the device while I'm scanning the barcode, then I can use that as an anchor. And that's become a very powerful tool for us. Just so to illustrate one of those ideas, that the image anchor, this is from Google I/O this year, 2019. No, yeah, I think so. Yeah, and they actually had directions in their app so you basically that's an image anchor, and after that, see, that is the inferred plane of that object. Okay? Then they superimpose. Here's where you go to the bathroom. Here's where you pick up the coffee, and so on. See what I'm saying? So they did that as part of the app, Google I/O app. But again, they had about 35 of these maps in different places. The problem is, okay, I tried it, and as I register myself, I want to walk over to the 265 feet away for some event. After that, if I lose track, I have no idea where I am, right? So in other words, you have to have a use case where everything that you do has to be around an anchor point. But it's not all development work. It's a lot of system integration stuff. Okay. Now, fortunately for a lot of my vertical use cases, they are much more manageable. And in this case, one of my customers said, especially in retail, they get, we're now coming up on Black Friday, right? This week. So Black Friday, there's a huge influx of new associates in these establishments, and they're all new, and they are totally untrained, and they're being asked to do different things in different locations. How do you even instruct them, right? So so our strategy here, and this has really gone over really well with the retailers, is how about delivering instructions to all these associates at the real world point of interaction? In other words, you're supposed to do something, some job somewhere, and you just hold up your device. It tells you exactly what to do, in your field of view. I'll give you an example. A big challenge that all these retailers have is something called buy online, pick up in store. How many of you actually order and then go pick up a grocery in your store? Anyone? No one? Somebody? Okay, so bottom line is you don't pay anything more for that. At least you expect not to pay more for that. And basically, you're expecting the associate to go pick it for you. The associate's spending 20 minutes picking up for your stuff, but who's paying for that? That's labor that they were not expending before. The prices haven't changed, and you don't expect to pay a premium for that. So they're all struggling, okay, with this idea of picking up in a store for an online order, but doing it efficiently. So what they do today, this is almost everyone has a similar concept. This is one of our associates, one of our customers. They actually have a multi-bin cart, and the actually associates are assigned to some aisles. Say, hey, you have the grocery aisle in this aisle, and the freezer aisle, and they actually are picking for 8 customers or more at once. So they have an app on one of our devices actually that tells them, okay, pick these products for this customer and this aisle and so on. But the problem with that is that they have this, what one customer called the Listerine challenge. There's so many identical looking products, right? And can you imagine, you only have like 1 minute to pick a product, and you have to keep on picking, and you have so many 8 customers to juggle at the same time. So you have you have to have an IQ of 130 or above to do this thing fast, yeah? So this is where they are actually, believe it or not, this is where they are today. And so the concept that we are developing prototypes for, and actually urge you guys to start talking to your customers about, is to be able to do this. So let's see if I can, yeah. This is not a mock-up. This is a real scene. He picked it. He picked that product. But the actual location of the product is exactly where that zebra is. The head of the zebra is showing the location of the product. This is just a prototype app, right, to demonstrate the value of this. And the placement of all of these is derived from the planogram that the retailer actually already has. You can see that all this animation is inside of that thing anyway, is very amateurish. That's my learning how to do these things from scratch. Okay, so the other use case similar to this is that you can actually compare. By the way, these are called planograms. So some in the headquarters, they define exactly where everything needs to be, and they define it. Believe it or not, say you have 4,000, 5,000 stores. Some of these retailers have 5,000 stores around the world, and North America alone, and for every store, they know precisely where every product, every shelf is, and where every product needs to be by design on the shelf. Precisely. I'm talking about within an inch of where each section is relative to the store, and within the store frame, exactly where. Not everybody has all of this, but this is where the industry is going. 3 minutes? Okay. So I'm going to skip past since I started 3 minutes late. But anyway, here's an interesting. Did I? Okay. Oh yeah, here's another thing you can do with it. You can actually put in training videos.
You want to make sure that you're paying attention to detail and that all the fruit is facing the same way. So with pears, we usually put the stem in and we stack thusly. With apples,
can have
we'll turn the apples and try to have them facing all the same direction so that they all fit and stack nicely on top of each other.
I mean, your imagination can go wild here. And this is something from our own repair center in Zebra. So we have this multi-carousel. We got about 12,000 components you have to be able to pick. And usually they're just told, okay, pick in row 5 and column 6 or something. And it's very error prone. So we mocked it up over here. The same idea, right, as before. Over here you can actually see physical interaction with the. So the augmented objects are extremely, the interesting thing is that if the augmented objects are stationary like this relative to the scene, it shows exactly how well the device is tracking. This is amazing. What's amazing to me is not the video, but the fact that the position of the device is being tracked precisely to the centimeter and milliradian. If it wasn't, the objects would not be stationary relative to the environment. You see? That is the magic of augmented reality on smartphones. And that's why this is going to be truly transformational. And this is another one with, I'm on a forklift here. So you're told where to pick a product in a warehouse. I just wanted to say one more thing about a complementary technology called 822.11mc, which gives you the location of your device using Wi-Fi round trip time down to 1 meter. This is not augmented reality, but it helps with augmented reality. If you know your position within 1 meter, then you can do all kinds of things that are to augment your localization. And then you can combine the two. And Zebra devices will have this. By the way, this is also called 802.11mc, and Google calls it Wi-Fi RTT. It became available. Again, not all devices have it, but those that do would be supported on most new infrastructures that are rolling out this year, like Cisco and Aruba and so on. So I'm going to skip this. So this is basically wrapping up. These are Zebra devices that I mentioned earlier, all of which have the augmented reality and .11mc potential. If you guys are ISVs that develop on Zebra devices, or I invite you to develop on Zebra devices, you have that additional features of ruggedness and barcode integration. And having the barcode integration helps a lot in terms of anchoring that I told you about, right? So that's basically my little commercial for Zebra. But other than that, yes? I'm sorry? Yeah, we have a booth outside. Yes. And you're welcome to come and watch our stuff. We actually will have a demo on this. Thank you.